We're going to get started. So I'll turn it over to Mark or Zelfix to talk to us about USB drives being encrypted. Here you go.
All right. So how many of you guys have experience with Linux? All right. Awesome. Awesome. So I have a few live DVDs here. If you have a laptop, you can insert those and follow along. It is going to go kind of fast-paced once I get started here. So in my GitLab there, I have all the syntax that I'm executing. On my YouTube page, I have everything that we're going over. So you can replicate everything I'm doing here. I also have on my archive page all the videos as well. There's a support channel in Telegram. I'm going to be using Parrot Linux to execute everything. They have about 2,000 people in the room, and the creator is there and answers questions. They have really good support, a great community. So I'm a dual certified Linux administrator. I just passed the 201 Linux engineer exam. Does anyone know what's going on in the background there? I'm curious. No one? All right, so I'm that's patching a Linux kernel with GR security, which is now gone corporate, so unfortunately. But that was back in the day when you could patch it and you had a really hardened kernel, so. All right. So just a quick reminder that the law is no substitute for morality. All right, so I have contributed a few things to the Parrot community. I wrote a pretty good paper on Tor and I2P, and that's on their website, as well as I have a full draft that I wrote there on my lab page. Like I said, the Parrot community is really good. There's the Telegram channel. I believe the IRC room died off, same as the XMPP, so I believe they're just going over Telegram right now. All right, so first we're going to go into wiping USB, formatting it with Parrot Linux, and then we're adding a persistent partition. We're going to encrypt the partition. We're going to add a Nuke Slot. We're going to back up the binary, because what the kill slot does is you're able to, once you encrypt the partition and you create a Nuke Slot, it makes the encrypted partition null and void. So it's better than wiping, because they still have not found a way to actually retrieve the data once you enable the kill slot. So basically, you create a password for the persistent partition, then you create a second password, and if anyone forces you to put in your password against your will, you're able to execute the kill slot, and the data is completely null and void. But you can also make a binary backup of the headers, and that way, if you kill it and then you want to retrieve it later on, you're able to do that. So I'm backing up the headers, and I'm also encrypting it with OpenSSL. All right, so if you want a disk, there's the disks there. I only created 5 because at CornCon I created like 25 and only 2 people took a disk. So if you want to download it yourself, there's the full and light. My disks have been verified. They have GPG signatures. I verified the integrity and the hashes of all those DVDs. So if you want here's all the mirrors. My slides are also up on my GitLab. All right, so first we're wiping the USB drive. So if you're unfamiliar with Linux, they have device files, which is the dev directory. SDC3 is the third drive. So right here, I'm using DC3DD, which basically just writes zeros to the drive. I have a video of this on YouTube if you want to follow along, but it's basically just one command. It's that first command there. So that wipes the drive. So Parrot ISOs are hybrid images, which means that the partition table and the boot record and everything is already taken care of. All you have to do is DD the image into it. I'm going to use Rosa, which is a GUI. Makes it a lot easier. So here are all the different URLs. Like I said, my slides are all up in my GitLab. I posted them in the Slack room. So if you want to go and retrieve them. They're there. All right, so I have a video, but really this is all it is. Right here, you choose the ISO, and then if you hit clear, it clears the drive's MBR, and then you hit write, it writes it to the drive. It's there's the video if you want to follow along, but it's really only like 5 seconds. Really easy to do. All right, so now we're getting to the more fast-paced part. You're going to probably want to pull up the syntax because it's going to go kind of fast. And there's the video URL of what I'm doing here. So give me 2 seconds here so I can separate the screens. By the way, this is Parrot Linux right here. I haven't done anything. I just wrote this. So all right. So this is what the syntax is going to look like. All right. Was that on top or something? Oops. All right, so this is the syntax file that's in the it's in my GitLab. So I'm gonna play the video. If you want to follow along, like I said, it's gonna go kind of fast. So, and if you want to see me afterwards, I can help you out. Give you the syntax file and kind of direct you along. Here we go. Once that opens, there it goes. All right, so this here is a program called disks. It just shows all the different partitions. If you see the last partition there is what we're formatting. The second partition is the MBR. The first partition is the live instance. So when you insert the USB, it's going to be booting that into RAM. It also has UEFI and grub, classic kind of booting. All right, so we're formatting the last partition there. So this is the GUI interface. There it's partitioned. I believe it has some sort of bug. So I also did the command line as well. So if you see here, I just formatted it with ext4. Can everyone see this fine? Let me see if I can increase the brightness. 1 second. Brightness is 100%. So all right. So we just formatted the partition with the ext4. Next thing we're doing is we're using encrypt setup, which encrypts that last partition with LUKS encryption, which is I believe the default is AES 256. So I'm creating a password now. Creating the password. Now it's formatting. All right, now we're doing the LUKS open, which opens up the partition is, it encrypts it like a container. So it has an outside encryption, and basically we're all here now, we are formatting the inside of the container with ext4 partition. So the dev mapper area is what maps device files in Linux. So we're also creating a label of persistence. This makes it so that you're able to start the USB in a live instance and it's able to open the encrypted partition on boot. So there, E2 labels it as a persistence. Now we're making a directory in the mount directory with a Parrot partition. Now we're mounting and binding the dev mapper, which maps device files with a directory. Now we're seeing the status of the container, of the LUKS encrypted container. You see here now the cipher is AES-256. All right, so this is a data LUKS dump command. This dumps, it shows the key slot. You see key slot 0 is the password, the regular password container. So that's the first one. We're creating a key slot 1, which is going to be the kill slot. Now the next command shows the device, and then the next one is the crypt tab, which shows the UUID of the crypt file, and then it shows the LUKS UUID label. Now we're adding a nuke slot. So we create a password. This is going to be a second password. So like I said, if anyone forces you to open it against your will, it's going to, you enter the second password that enables the kill slot 1. So the kill slot 0 is the default. Kill slot 1 is going to be, or key slot 1 is going to be your kill slot. So I just added a nuke slot. Now I'm going to, now you see the key slot 1 is enabled, which is going to be your kill slot. So now, let's see. All right, so now we're making a backup of the LUKS headers. Now, if you see here, I did a ls, which shows all the files in the current directory. ls and then the file, and then file shows the file type and all the details about the file. You see here it's a LUKS encrypted file, and it shows the type of encryption it is, and it shows the file location. Here I'm using OpenSSL to encrypt the backup header with AES-256 CBC. Now we'll run an ls, and you'll see there's two. There's the LUKS header back and LUKS header back encrypted. The encrypted is the file that was created with the OpenSSL encryption file, and you can see OpenSSL encrypted data with salted password. All right, so now we're running OpenSSL, and we're decrypting the file, the LUKS header backup file. LSing the directory, listing the directory. Now you see there's the file after decrypting it. I believe that was about it. Let's see. Can't remember if there was any more to this video or not. All right, now I'm copying the syntax. So I have a script with all the syntax, and I'm copying it to the mount directory inside of the encrypted persistence. That way, if you ever need to reference it, this is what it looks like. So if you see here, partition, and then you see the second one here is the LUKS encrypted persistence. Like I said, the encrypted persistence is like a container. So you have this second thing that's inside of the first one. So it encrypts basically the outside area and encapsulates the persistence ext4 partition. So that's the mount area. Like I said, I copied the script that I wrote for this to that directory. That way, once you open up the encrypted persistence, after you live boot, it's there, so you have all the syntax. Now I'm unmounting that directory, then I'm closing the LUKS partition with crypt setup. Now you see there's only one thing there, it's locked. So I unmounted it and I locked it. So, like I said, this kind of went kind of fast. If anyone's not used to Linux, you can see how they could be easily lost. So, any questions? All right. So I put the syntax URL in the Slack room, as well as the YouTube URL. It has everything that I went over, as well as I have an archive.org URL with everything. Feel free to take any DVDs. I guess that's it, unless anyone has any questions.
Thank you very much. A short break, then we're going to wrap up with the results of the mini CTF and close it down. So 5 minutes, we'll wrap it up.